Okay, hello, this is Dr. Janes, and today I'm going to talk about Polyphase, high-frequency Polyphase generator from a Teensyduino. Let's take a look here. Tesla was very interested in polyphase, so he wanted to create three-phase to create a rotating field. And I have two probes here, and I have them hooked up to my scope. And as you can see, they are 120 degrees out of phase. And there's actually three phases here, but I don't have three channels. And I show in my other video how I can change the frequency. So I have Teensyduino here, and I put a frequency adjuster here so that I can twiddle with this guy and change the frequency over here. I don't know if you can see that, but it's hard for me to hold all this. But okay, let's see if we can do this. There we go, twiddle with the frequency. And so I have a polyphase, high frequency, three-phase generator. And you may ask what I'm going to do with that, and I'm not going to say right now, but it's going to be an interesting project. And let's talk about the code for a little bit. Let me shut this down. Okay, so if you watch my other video about the high frequency signal generator using a Teensyduino, this is a modification of that, where instead of one output, I made three outputs on 13, 14, and 15. And then I do digital writes, write the first one high, the second one high, the third one high, then the first one low, the second one low, and the third one low. And then I just repeat that pattern how many cycles I want. And go all the way down to the end. And of course, here's where I get the tuning part. I do an analog read, so it'll do a burst of three-phase at a certain frequency, and then it'll stop and then do an analog read. And this is a simple way to do it. It's not the most optimum way. And of course, I mentioned in the other video that I needed to add something from the loop to do the delay, because the optimizer would just skip over this and optimize it too much, and it wouldn't do any delay if I had something simpler, like just add one or something. So I have an offset in the delay, which sets the frequency, plus B, which is the analog read, which is determined by our potentiometer here on the Teensyduino here. Teensyduino here. Okay. And that's pretty much it. This is a for loop here, and this is what institutes the delay to give you the variable frequency. Okay, I wanted something with a low clock cycle count, so I'm just doing an add. But if I just added one, like I said, it would just optimize. The optimizer is so smart, it would say, oh, okay, I see, this should be like this times the number of loops or whatever, and then I'll just put that in there. So if I put some integer that's changing based on the loop, it's not smart enough to optimize that away. So it actually does this calculation and how many ever clock cycles that takes, and it does the very quick delay. So I can get fine increments and high granularity in the different frequency resolution. Let's put it that way. Okay, and I changed num. Num is the offset. On the other program it was 400, but since I have three phases here, I changed it down to about 100, and that gives me pretty much the frequency range that I want to try to sweep with this very interesting high-speed polyphase frequency generator. Okay. And anyway, this is Dr. Janes, and thanks for watching. This is Dr. Janes, and thanks for watching.